In section 7.5 in algebra, you're dealing with special linear equations. So let's go over what we've done so far. We've done graphing, we've done substitution, where you isolate one variable for one equation and then substitute that whole thing to the other, and then elimination, where you try to get one equation, both equations with opposites, add them together and eliminate. Okay? So in this section, you're going to learn about special circumstances, and also you're going to choose between your methods. So if there's a particular one that you have, if all else fails, elimination always works. Okay, if all else fails. Some of you guys will completely avoid graphing, and that's fine as long as you can figure out what it is. So if you're not sure, just stick to elimination. But basically, this is what we've been dealing with. One solution. That means that the lines intersect, giving you one answer, and that point says that that point is the same for both lines. It'll be an answer for both lines. Now sometimes you'll end up with the same slope. Okay, you remember that, the m in the y equals mx plus b? When you end up with the same slope, that means the lines are parallel. They'll never intersect, so you don't have to worry about it. This one, that means they have all the solutions. So basically what you're doing is you're essentially drawing the same line. When you draw the same line, okay, that means both lines intersect overall. They share all problems. So let's try this one. This one has an equation all by itself. So I'm going to go ahead and use substitution. Okay? So the method I'm going to use is substitution. Okay? Doesn't necessarily mean you need to graph it. So let me show you how to do it without graphing it, because this is showing you the graphs and that's the only way you find out. But it doesn't necessarily mean that. So let's solve this. Okay? Negative 6 plus 2y. I'm going to solve this one right here for y. So I'm going to add 3x to both sides. I end up with y equals, y equals 3x plus 7. Okay? So I'm going to go ahead and plug this in to y here. So negative 6x plus 2 times 3x plus 7 equals negative 8. Okay? I'm going to bring negative 6x down. I'm going to take positive 2 and distribute it. Remember those parentheses, always need to distribute it. So I have plus 6x plus 7 equals negative 8. So negative 6 plus 6 cancels out to 0. I end up with 7 equals negative 8. Well, this by chance, when will 7 equal negative 8? Never. And I got rid of the x because they canceled each other out, so this will be never. So what that means is I'll end up with no solution. Whenever I end up with two equations that will never equal each other, this is called no solution. What that means is if I were to graph these, they would have the same slope, so they will never intersect, so then it cancels out. So I end up with no solution. Right? Go ahead and write this down. We're going to do one more example. So this one says solve using any method. Because I used substitution last time, I'm going to use elimination this time. Alright? This is y and this is 2y, so let's multiply this, okay, by negative 2. If I multiply this by negative 2, then that means this would become negative 2 and positive 2, and then we'll go. So I'm going to bring this over. Okay, and then I'm going to bring this over. So negative 2 times negative 2x gives me negative 4x. Oh, sorry, negative and a negative give me positive. And then this negative 2 to y gives me negative 2y. And then negative 2 to 3 gives me negative 6. So, now I'm going to add. Negative 4 plus 4 gives me 0. Negative 2 plus 2 gives me 0. Okay, and then I have negative 6 plus 6 gives me 0. So this is very similar. I got rid of all of my variables. But the question is, when does 0 equal 0? The last time we had, when does negative 7 equal 8? And that's never, so that's no solution. But 0 will always equal 0. So if I have 2, when will 2 equal 2? When will 3 equal 3? When will 0 equal 0? All the time. Okay? So when that happens, it's all the time, then this is all solutions. That means, basically, if I were to graph these, okay, they would be the same, they would be essentially the same line. Okay, when I move everything over, I'll start eliminating and reducing, and then they'll end up being exactly the same line. So they overlap on all points. There's not just one point that they have an answer. Okay? So try page 418 number 2, and I will see you in class.